The third set operation we're going to look at is known as set difference. And what set difference enables us to do is bring back unique items from either set A or set B. And in Venn diagram form, this would pertain to just the left segment, i.e. excluding the middle segment or the right segment, or we could also find those items which are in the right segment, excluding those which are in the middle segment or the left segment. Now the set difference operation is performed using the minus operator, and the same can be achieved by using the difference method. So let's see some examples. So if we wanted to see the items in A that are not included in the items of B, we could put A minus B, and this will bring back the integers 1, 2 and 3. This is because 4 and 5 are also included in set B, and because we're looking at the difference, it's only integers 1, 2 and 3 that are unique to A. If we wanted to find what was unique to B, we could put B minus A, and then we bring back the integers 6, 7 and 8, because 6, 7 and 8 are unique to B. 4 and 5 are shared with A. Now we can also perform the same operation using the difference method. So if we put the variable A and then put dot difference and we pass in set B into parentheses, we get the result 1, 2 and 3, just as if we had written A minus B. And if we wanted to see what was unique in B, we could also access the difference method on B, so we could put B dot difference, and inside the parentheses we can put A. When we do this, we bring back 6, 7 and 8, which we know could be stored in a separate variable and then used later in our code. So the difference operation will enable us to find the unique values in each set compared to another. Now the final set operation we're going to observe is known as symmetric difference. And what symmetric difference allows us to see are those items that are included in either set A or B, but if they are shared, we will not show them in our result. And the way we can perform symmetric difference is by using the caret operator, i.e. the little arrow that points up. And the same can be accomplished using the symmetric underscore difference method. So let's see it in action. Seeing as we know that items 4 and 5 are shared between sets A and B, these would be the values we expect to be removed from our final result. So if we put A caret B, you can see we get a result set 1, 2, 3, which is from set A, and then 6, 7 and 8 from set B. 4 and 5, seeing as they are shared values, will not be included in our output. Now because there is only one result set that can be obtained, it doesn't matter what we call the symmetric underscore difference method on, it will obtain the same result. So if we put A dot symmetric underscore difference and then pass in B to the parentheses, we get 1, 2, 3, 6, 7 and 8. And if we were to also call the symmetric underscore difference method on B and then pass in A into the parentheses, we once again get 1, 2, 3, 6, 7 and 8. So the symmetric difference operator allows us to obtain the values from both sets, but those values which are shared will not be included in our final result. The next set operation we're going to cover is known as set intersection. And set intersection can be visualized as follows. It brings back the middle area, i.e. the middle intersection where both sets cross over. And we can perform an intersection operation by using the AND operator, i.e. the ampersand symbol, and we can also achieve the same result by using the intersection method. So let's see a couple of examples. If we use the two sets created in the prior video, i.e. A containing integers 1 to 5 and B containing integers 4 to 8, if we type A ampersand B, you can see that we bring back 4 and 5, as these integers are shared in both sets A and B. Now because the intersection relates to items that are shared, it doesn't matter how we call the intersection method. So if we call the intersection method on our A variable, and then inside parentheses pass in set B, we get the same result showing 4 and 5. If we were to call the intersection method on variable B and pass in set A into the parentheses, we also bring back 4 and 5. And we could then save this in a separate variable in order to use elsewhere in our code. So set intersection enables us to combine two sets and obtain the values that are shared in both.